So we're going to start by looking at nuclear radiation, and we're going to come across a few new equations. So radioactivity, in 1896, Henri Becquerel was investigating the properties of uranium salts, in particular, their glowing in the presence of light. And by accident, he discovered that uranium salts were producing radiation which could turn a photographic film black even when the film was wrapped in paper and stored in a dark drawer. Now, normally photographic paper only turns black when it comes into contact with light, so something was going on there. He then went on to do further experiments which showed that this new type of radiation could easily penetrate materials such as paper, but not metal objects like coins and keys. Marie Curie later gave this process the name radioactivity. It's also known as nuclear decay or radioactive decay, and it's the process by which the nucleus of an unstable atom loses energy by emitting particles of ionizing radiation. So basically, some atoms have a nucleus that is unstable. And what it wants to do is it wants to change into a different type of nucleus. And to do that, it emits particles and it changes into a different type of nucleus. And there are different types of particles that it might emit. And a material that spontaneously emits this ionizing radiation is considered to be a radioactive. So just a reminder about the structure of the atom. There are protons and neutrons inside the nucleus and electrons that orbit outside the nucleus. And as I said, the nucleus in some atoms is unstable, and these nuclei become more stable by the process of radioactive decay, where they spit out particles, radioactive particles, and become different types of nuclei. There are three different types of nuclear radiation: alpha, beta, and gamma. Okay, and if you have a read through the notes here, you'll see they have different properties. So alpha particles are big, they're 2 protons or 2 neutrons, so they're the same as a helium atom. They're positive because they contain 2 protons, and they're relatively slowly moving. That doesn't mean they're not fast, but they're slow compared to other radiation, about 0.1 times the speed of light. They can also be stopped by a sheet of paper, and they can't get very far in air. Beta particles, they are fast-moving electrons. They're negative because they're electrons, and they travel almost at the speed of light. They can travel a lot further than alpha particles. They can get through paper, but they're stopped by perspex or aluminium. Gamma radiation is not a particle, it's a wave, and it can get it's got a range in almost infinity, so it can get really, really far. It travels at the speed of light, so it's the fastest, and it's extremely penetrating, so it can get really far in air, and you have to have a lot of lead or a lot of concrete to stop gamma. There's a little summary diagram there. Alpha particles get stopped by paper, beta go through paper but get stopped by aluminium, gamma go through paper and aluminium but get stopped by lead. And although our alpha particles can't get very far in air, because they're the biggest, they are the most ionizing. Now, ionizing means loss or gain of an electron from a neutral atom. So because alpha particles are so big, they can knock away electrons quite easily. Beta particles are quite ionizing, but gamma particles aren't as ionizing as the others. So if you do come in contact with alpha particle, they're very ionizing, and having ionized elements in your body is not good. It's a quite bad thing. So alpha radiation is more ionizing than beta. Beta is more ionizing than gamma. And I'll let you have a read through nuclear radiation detectors.